Hello everyone, welcome to the channel. Today I'll be going over Oracle database architecture. I always felt like, or I still feel, that a database administrator is kind of like a mechanic, and you can't fix a car unless you know how it works. So today I will be, at a high level, be explaining how the Oracle database works, but using a story. I just believe that stories are also much easier to remember and much easier to retain. So I'm going to try to tell this story from Sarah's perspective, an HR manager who is trying to update payroll information for the entire company, say like a bank. And I want to just break down how this operation will, basically happen in an Oracle database. So when Sarah goes ahead to, execute her query from her personal computer, and she wants to update the salary for all employees for the upcoming year. At the application level, a user process is born, okay, from her computer. Now that user process travels over the network, which is this blue line right here, and just before this point, it meets what's called the listener, okay? Think about the listener as the gatekeeper. The listener has the ability to check the credentials of the user and see if this user is allowed to access the database. And based on the kind of query that the user wants to run, then the listener has a decision to make. Should I give this guy a dedicated server process or a shared server process? Now, because of the nature of the update that Sarah is trying to run, Sarah will need a dedicated server process because it's resource intensive, right? So the listener will grant the user passage, right, and assign it a server process. Now, the user process only speaks application language, but the server process speaks application language and database language. So think about the server process as a courier that is going to go into the database and perform operations for the user process. There are four main things that the server process does, right? It parses a SQL statement, which is like understands it, executes it, retrieves information, and returns that information to the user, okay? And in order to do that, the server process is assigned what is called a PGA, basically a private mobile office where it can execute, do its computations and executions and everything. The server process walks around with its PGA and gets into memory, Oracle's like memory architecture. The first part that it touches at the memory level is the shared pool, which is kind of like the brains of the operation. The shared pool has two main components, right? Library cache and a dictionary cache. In the library cache, it stores execution plans, right? So in the library cache, the server process is going to check, oh, has this report been done before? How was it done? Basically, the execution plan of if it has been done before, will be in the library cache, which is going to be called a soft parse. If that execution plan is not in the library cache, then we talk about a hard parse, which means the optimizer has to devise a means of executing that plan. And then we move over to the data dictionary. In the data dictionary, think about data dictionary as where metadata is stored, right? So it's like where the tables are located. The table information, index information, permission information, things like that, right? So we also want to know, does this user even have the privileges to be able to make this update? Should he be able to view this data? All that determination is made in the data dictionary. Once we pass the data dictionary, then we're moving over to the buffer cache. The buffer cache is kind of like a waiting area, right? So, Sarah is trying to make a bunch of updates. Now, he wants to update think about it like Sarah wants to update certain books or certain files. Now, in the waiting area, files which are accessed the most are kept here. Think about it like, any storage environment. When you go, the materials that you need the most, you keep them in the front, which will be the buffer cache. And then the other ones that you don't need so often, you keep them in the back, which will be in the data files. We'll get to the data files later. So within the buffer cache, Um, if the again the data that needs to be updated is in the buffer cache, that's called a cache heap. If it's not and it's in the data files, it's called a cache miss. Now, the user process through the server process will write all the updates into the redo log buffer that it wants to make into a redo log buffer. Think about the redo log buffer as, I don't know, a diary, a daily diary. You have to write all your changes here first before they can be effected in the database. That way, the database is keeping track of everything, right? And then think about the Java pool as a graphic designer, within the database. Because when you request information from the database and you want it to look beautiful and legible so that, the managers and everybody who else is getting the output can read it. So you have basically a personal graphic designer in the Java pool, which, will make all those Java operations on your behalf. And then the large pool is just extended memory. So usually for most queries, you should be able to take care of them within the shared pool, right? But again, for a query like this one, which is very resource intensive, you might need more memory for parsing, parallel execution, and things of that nature. And that's when the large pool comes in, right? Give you more memory to be able to use. Now, we come to this area here, which are the background processes, which I like to term the unsung heroes, right? The unsung heroes. What's the purpose of the background processes? You think of SMON as a janitor, system-wide janitor. It knows operations are coming, so it cleans up, creates space for the next operation which is coming in. The process monitor, think of this as a personal assistant to the server process. It helps the server process. It knows what the server process is trying to do, and it kind of like helps the server process be more effective by helping it out. And then you have the DB writer, the log writer, and the checkpoint. Think about checkpoint as a coordinator, right? For all the changes that are written into the redo log files, those changes, the redo log buffer, those changes have to be written into the redo log files. They have to be written into the data files for permanent storage. Somebody has to track all those changes and tell the log writer when to write those changes from the redo log buffer into the redo log files, and also tell the DB writer when to write those changes into the data files. So the checkpoint is there doing the coordination and also keeping track of everything in the control file, right? Think about the control file as, I don't know, like the blueprint. So the checkpoint keeps updating the SCN in the control file, telling and the data file headers, right? To keep track of everything, just coordinate, make sure that there's read consistency within the database, right? So data files for permanent storage, redo log files copies changes dirty blocks from the redo log buffer into the redo log files. And so that's pretty much how the life cycle of a SQL statement in database. Just to go over from top to bottom again. So the user process sends the SQL query across the network. Listener receives the request, sponsor server process. The server process checks the shared pool for cache execution plan. The server process then verifies if the permissions via the data dictionary. The server process searches the database buffer cache for data blocks to see if the data that is being queried already exists in memory in the buffer cache. If it's a cache miss, then the server process reads from the data files, right? Like we discussed. Now, then you have the background processes working, DB writer, log writer, and so forth to maintain system integrity and also enhance efficiency. And then the server process returns the results to the user process. And Sarah is able to get the results that she wants, after performing the update. And if she queries, she will see. And then also, if this query had not been executed before, now it's going to get stored. different portions of in the library cache and data dictionary and the buffer cache and so forth. So if it wants to get run again, then it doesn't have to go back to the data file. So that's basically how the architecture works. Obviously, there are so many other components that we haven't been able to touch because this was just a brief overview, like going to the data file component. You have to study table spaces, blocks, the different types of table spaces that we have in the database and what they are used for, things like that. So there's so many other background processes as well that we can get into, but this understanding these ones gives you like an overview of how everything works, and then the others will just be a plus. I hope you enjoyed your time with me today, and looking forward to seeing you for future classes, I guess, or future conversations. Thank you so much for staying to the end. I'll talk to you soon.